Good morning, good afternoon, good evening, wherever you may be. Welcome to this episode of Spectra Geospatial and our partnership with Aplitop Tunneling Solution. I'm presenting today. My name is Joe Sass. I know many of you I do not know. I am with Spectra Geospatial in the capacity of a field applications engineer. Basically, I'm involved in any pre-sales activities and whatever it takes to help Spectra Geospatial be successful. That's what I do for a living. I work with Riley Smith. Riley Smith is the market manager for Spectra Geospatial in this space. He has quite a bit of experience in both tunneling and mining. He's stationed out of our Westminster office in Colorado. And then our partnership is with Aplitop software. Aplitop is a well-known software based out of Malaga, Spain. And today we have Hugo Perea and David Vargas. David Vargas is the software developer, and he will actually give us a live demonstration of the software. And Hugo is the sales representative that we will liaise with if we want to do business with Aplitop. Did I hear a comment or a question in the background?
No, I think you're good.
So, Hugo, would you speak to this slide, please?
Yeah, thank you, Joe. Thank everyone for joining this Spectra and Aplitop webinar. My name is Hugo Perea. As Joe said, I'm the sales manager for Aplitop. Aplitop has been in business since 2004. It's a software development company based in Spain, focusing in the civil engineering and topography sectors. We work through an extensive network of dealers present in more than 75 countries up to date. We have sold more than 18,000 licenses to professionals in the civil engineering sector and topography sector. The strongest point of our software is the friendly user interface. It's very easy to use, easy to learn, which make it quite easy to sell for non-technical people. Most of our dealers are not topographers, are not civil engineers, but they manage to learn how to use the software and how to sell it. We also have an extensive academy online in Aplitop with tons of videos about how to use our software. And we can serve our licensing in a permanent subscription or in an annual subscription. We always encourage the annual subscription because it's included the maintenance, the support, and the support is recommended by more than 98% of our customers, which renew our support contracts every year. Today we're going to see our software for tunneling solutions, which are TcpTunnel and TcpTunnel CAD. TcpTunnel integrated into a Spectra Geospatial device, and TcpTunnel CAD for desktop solution, which can be used on AutoCAD, CWCAD, BricsCAD. And among our customers are the main players in the construction industry all around the world: Dragados, ACS, OHL, FCC. And we have been awarded as an innovative company, as we are constantly developing new solutions for the civil engineering sector. So as I summarize, we are a software company in the civil engineering sector with very profitable software in terms of a lot of functionalities compared to the pricing it has, and very easy to learn, very easy to use, and a high world-class level support. Thanks, Joe. Thanks for your time.
Thank you, Hugo. Just a comment from Joe Sass. I have a lot of land survey experience, and I have very little tunneling experience. However, I was asked to test the software and make sure that it was integrated well with our hardware. And I've got to tell you that tunneling software is very similar to land surveying. It's the same. We use alignments and templates, and that's exactly what this software does. And speaking to the ease of use, it was very easy for me to step into. I needed very little instruction, very little support, very little help, and I was able to run my robotic total station quite easily with the Aplitop solution.
Thanks, Joe, for the
Oh.
insight. That's right.
Video. One of the scenes in that video was very telling to me, because I worked quite closely with Aplitop and our development engineers out of Germany on the what's called the software development kit that allows their software to talk to my robot. And they are actually doing like the surface scan feature, which is part of that video. They're doing that better than I do it myself. They found a technique within that SDK that allows them to do surface scan at probably 2 or 3 times the speed that my Survey Pro does that at. It's not an important feature of Survey Pro, but it is very important to the Aplitop solution, and they've done it. They've maximized the efficiency there. So tunnels, they look different, but they're all the same. They come in a lot of different shapes and sizes, but they're holes. They're tubes in the ground. They are alignment and template based, station and offset. They use a few words that we're not used to using: overburden, underburden. But for the most part, the syntax is the same, and the workflow is the same as a land surveyor is doing today. It's just in a very specialized environment that's tubular and linear. Tunnels are everywhere, and they're constantly being built and maintained, and it's a large business opportunity for land surveyors. Tunnels, there's even books written about tunnels, right? So tunnels are everywhere. They're part of our life. So what are some of the challenges and the solutions waiting for tunnelers? And I'll let Riley speak to this. Riley?
Is on mute,
Riley?
of course.
There,
All right, sorry about that,
Thank
everyone.
you.
So how I look at the challenges is there are really 3 categories when we're talking about tunnel surveying. And the first one, one of the bigger ones, is construction downtime. Anyone who's worked in a tunnel or has been a survey or construction side of things knows that it's a pretty go-go process. There's not a lot of time to lose, because each minute, each hour that the equipment's not working, whether it's the TVM or the road header, whatever it might be, that's a lot of money that's being wasted essentially. So it's really important for the survey crews to be able to keep up with that equipment and be productive while they're in the field. And so that's why productivity with any technology, whether it's the total station or the field software, is very important. The second point is all about quality control. We're a big requirement on tunnel projects is understanding the position of that tunnel as it's being built and making sure it conforms to the design and the specifications. So really with the software, this is all about confidence in the data that's being collected and the traceability. So understanding the raw data, having the raw data from the measurements to know that what you collected in the field is right and in the right position. So we have that confidence as the tunnel is being built, that it's in the right position. And the last is all about efficiency in the field. So having workflows that are simple and concise and help, once again, with that top category in productivity, but also efficiency. We're removing errors by having more automated workflows, reducing the amount of manual operator input that's needed. I don't need to point to every point anymore. I can run automated routines that collect all of those profiles automatically and help set out those points automatically as well. So those are the 3 big challenges and 3 ways also how to solve them. And I just want to mention one thing. If anyone wants to view this presentation afterwards, there is a PDF attached to the GoToWebinar. So if you go to the little pane probably on the right-hand side, it says handouts, and there's a PDF attached, which will have links to everything as well as all these slides.
Thank you very much, Riley. Well said, well spoken, thank you. Somehow my down arrow is not working on my computer, I don't know why. So what does it take to build a tunnel? It takes an office component and it takes a field component. And in the office, we're designing the tunnel, or we're quality checking or reporting about the tunnel afterwards. So there's both a pre-field component and a post-field component. And then if we look over here on the right-hand side, the robotic Focus 35 robotic total station is integral to this solution. And then as far as the data collection platform, we're recommending either the ST10 or the Ranger 7 with a preference to the ST10. It just seems to work better. There's not a lot of typing that goes on in tunnel surveys, so you don't really need the keyboard that the Ranger 7 offers. And notice also that there is an AutoCAD component in the design portion of this. Soon that will be a standalone portion not requiring AutoCAD, but today that is one of the requirements. So the pre-field part, this is where we create and design our alignments. It's not really a point-based workflow, it's an alignment and template-based workflow. And basically we're trying to do our stakeout for the blast and drilling so that we can actually shape our tunnel. Once we've done the drill and blasting, we need to actually get the as-built, and that's where the automated data collection comes in, where we can actually do surface scans and see how close we are to that design and what our overburden and underburden quantities are. We can do the quality control checking right here once we built the tunnel or laid it out and done the blasting, so that we can know how close we are to that design, right? That's the end game right here, is how close can we get to the design and what are the deltas between what we built and what we designed. So looking at it in maybe a more broken out way, we start in the office, we have projects, so that's the actual tunnel project probably, or tunnels. Many of these are multiple tunnel definitions. And then we create and design the templates and the cross sections. We assign the cross sections along the alignment, right? Then we take the total station out there and we stake it out. We lay out those points. We put in the points where they're going to do the drill and blasting. And then once they've done that, we actually do the surface scan and make sure it's done right. And we take all that information back into the office, and that's where we can do our reporting. And that's really the main thing, as Riley said earlier, the accountability and the liability, I guess is the word he used, is a big part of tunneling that may not be so important in land surveying on the surface, but becomes very important when you start going underground. So tunnels can be defined in a few different ways, and this is just showing you two examples where it basically usually has a radius point that defines how the roof and the sides are going to be defined, whether or not it's a full radius as you see there on the left, or whether it actually has a left and right sidewall that are vertical before you go into the radius component or the arc component there. Sometimes the ground is flat, sometimes it has a side slope, as you see, just like we do in roads. And so you can actually see there we have super elevation possibilities, which is straight from our roading catalog that we are familiar with today. Nothing there is surprising, except maybe the way the files are named. Once we've done that design and we've assigned the cross sections to our alignments, it's now time to go out to the field, right? And we're going to do our layout, our survey. We're going to do the cross sections, and to find where the bolts go, where the surface points are, the front cross sections, the front. We go out there, and as you can see in the screen captures provided, these are nice big icons that are fully clickable with gloves on. This is, as Hugo indicated, this is a very simple program to to actually interface with. And it's not hard to negotiate. And if you don't find it on the first button click, you're going to find it on the second button click. It's that close to the surface with all of the routines and features of the program. To that point, I talked with Hugo prior to this presentation, and he's wide open to anybody on this call that wants to test drive the software. Work with Hugo, and he'll let you have a copy, probably a timed copy, where you can interface with the software. If you have a Focus 35, even better. But without the Focus 35, you can still get the look and feel of the software quite well. So we've done our field work, and we come back to the office. And these are just a few examples of the office deliverables where we can actually do 3D modeling. We can do our volume calculations. We can visualize. We can generate reports. We can compare the as-built to the design. Get our calculations about the volumes involved in those overburdens or underburdens. I think I'm using the wrong word. It's over what? Is that the right? I think I'm using a mining term there. So sorry if I am.
That's the right term. The other way I usually hear is over and under break.
Under break, that's it. So sorry if I misspoke there a little bit. I think you guys understand what I'm saying. Thank you for the correction, Riley.
Yeah,
so these are just
similar to cut and fill. That's how if you're do a lot of road construction, that's how I think of it too. Cut and fill, very similar.
Over break, under break, cut and fill. Nice. So this is just an example of some of the deliverables. There are obviously a lot more that can be provided, but in the context of a webinar, we're not going to go through the weeds, so to speak, on that. So with that being said, I'd like to turn the presentation over to David Vargas, and he's going to run through a practical presentation of the software and show you more of a real demonstration of the workflow involved in the TcpTunnel CAD. David? Riley?
Thank you. Well, I'm going to do the presentation of TcpTunnel and TcpTunnel CAD, following the workflow we have seen in the previous slides. So I'm going to start creating the project in TcpTunnel CAD. Then I'm going to do a survey with TcpTunnel, and then I'm going to go back to TcpTunnel CAD to draw the top sections and doing the 3D model of the tunnel. So the first thing we have to do is to create a folder and copy inside the files of the project. In this case, we have a land SNL file with the horizontal and vertical alignment definition, and also a DWG file with the tunnel template. So we go to AutoCAD, and then this is the TcpTunnel menu. You have the option to create the project, to create the tunnel templates, to do the cross-section calculations, to do the reports, and also different options to such as 3D model, compare cross-section, etc. So we start creating the project. Then we go to the project folder and the name. And then here we set up the main author, how we want to create the templates. Then we are going to import the horizontal and vertical line. Now we go to horizontal alignment editor, and then we select our land file. We enter the name for this alignment, and this is the horizontal alignment of the project. Then we do the same for vertical alignment. Open the vertical alignment editor. We go to the same folder and select the same file. And here we have the vertical alignment of the project. Then we have the vertical horizontal alignment. We select the tunnel template file, and then also the control point to do the resection in TcpTunnel in the field. Then we press OK, and we have created the project. Now we are going to open the drawing with the tunnel template. In this case, we have only one tunnel template. Then we go to TcpTunnel, edit tunnel templates. We click on new and select the polyline that defines the tunnel template. We enter the name and select the horizontal and vertical alignment point. And then we click on OK, and we have here the tunnel template created. Then the next step is to go to tunnel template assignment, and then here you have the tunnel template we have created in the project. In this case, we have only one, and then we have to enter the final station we want to use with this tunnel template. In this case, we have only one, and then we use this tunnel template for all the horizontal alignment. Then, after doing that, we can draw the tunnel.
So David, this is Joe speaking. If the tunnel changes its shape, then you would need a new template. Is that correct? And then you would have some type of a.
Yes. You can add different tunnel templates, and you have to go to TcpTunnel tunnel template assignment to set up which tunnel template you want to use along the horizontal alignment.
So the tunnel you're building now, though, has the same shape inside all the way along because it's only got one template assigned. Is that correct?
Yes.
Thank you. Sorry to interrupt.
So here we have the tunnel, the theoretical tunnel in 3D that you can view in orbit. This is the theoretical tunnel. And then after creating the project, we can go to the TcpTunnel program, and then select the project we have created in TcpTunnel CAD. Then we select the project here. Here you can see the components of the project we have created. And then the first thing we have to do is to create a empty point file to store the points we measure in the survey. And then the next step is go to positioning options. In this case, we are going to do a resection. We enter the name of the standing station, or select from the file. And then we measure the different control points. We are going to measure the first one. I'm going to measure the second one. And we do the same for the third. And after doing this, we have the coordinates of the standing station calculated, and here the errors calculated. Then, after doing that, we can go to different options in survey, or stake out, or check. Then we are going to survey some cross sections. Then the first thing we have to do here is to define the theoretical points we want to measure. So here we have different methods by length, angle, or height. Then we set up here the interval, and also we can set up here difference filters. In this case, we have the method length, and we use 1 meter interval. And this is the result of the point we want to measure. Then, after doing that, we have to enter the initial and final station and the interval. In this case, for the demo, we are going to measure 2 cross sections. And then here we can start the cross-section survey. Below you can see the theoretical station, the measure station, and the difference between the theoretical points and measure points. Here the total station tries to find every point in the theoretical station. After finishing the surveying, you can see here the difference between the theoretical point and measured point. And after finishing, yes.
Question, David. So just so everyone's aware and for clarification, the total station used its position from the resection and then it automatically measured those profiles, the cross-section profiles, yeah.
Yes, yes.
Awesome.
So after doing that, we can go to check, for example, and calculate in TcpTunnel in the field the areas, the overcut and overbreak and underbreak areas. So we analyze the points, we enter the interval, tolerance, we set up. And here we can see and calculate in the field the areas, overbreak and underbreak areas.
That's very useful.
And then we can do it in the field. We don't need to go to the office to do that. And then after doing the survey, we can go to the office and process the data. And then we go back to TcpTunnel. And here, the only thing we have to do is to select or import the points we have surveying in the field. We edit the project. In this case, we are using the same project, but the only thing we have to do is to select the point file we have created in the field. And then the next step is to calculate cross sections. Then we enter the initial and final station and the same parameter we have used in the field. And then we enter the name for a cross-section file. And then after creating the cross-section file, we can run all the items in the menu of TcpTunnel tab. So we can go to draw cross-sections. And here you can see the cross-section we have surveyed the field. For each point, you can see the name of the point, the number of the point, the difference between the theoretical measured cross-sections, and the height of the points. And below, for each cross-section, you can see the station, the horizontal X and Y coordinates, the vertical alignment height, and overbreak and underbreak areas. Now I'm going to change the cross-section file to do more a volume report. So I'm going to edit the project, select a cross-section file we have here with more information. And then after doing that, we can edit cross-sections. Here you can see the cross-section we are measuring the field. You can edit and modify the cross-sections. You can create different reports, like volume reports. Here you have the station, the length, the overbreak and underbreak areas and volumes. You can print the reports in different formats, like physical printer, ASCII file, web file, or Microsoft Word or Excel. And also, you can compare different cross-sections measured in different days. For example, we are going to compare the excavation and concrete cross-sections. We can here, for example, here you have the volume report, and also you can draw.
David, while that's calculating, there's a few questions that came in. One question was what design formats can we import and use with TcpTunnel CAD? For instance, can I import an IFC file and use that with TcpTunnel CAD?
Can you repeat? I don't understand the question, Ray.
Yeah, so if I already have a design file, can I import that design file into TcpTunnel CAD and then use it for creating reports? For example, land XML or IFC?
You mean the theoretical tunnel template?
Yes.
No, now you can in TcpTunnel CAD you have to create the tunnel template from the drawing.
Can you can import though alignments, right, from?
Yes, you can import alignment from land SNL file, but the tunnel template you need to do it from the drawing, or also like a TXL file. You mean that?
Yeah.
You have the option like this, where you can, let me see, here you can import a TXL file.
Okay.
From PVC. You mean that?
Yeah, that answers the question. Okay. Thank you.
Here, this is the option to compare cross-sections. And here you can see the concrete cross-sections, the concrete cross-section, the excavation, and also the theoretical tunnel template. And here you can see the difference between them. And also, to finish the demonstration, I'm going to create the 3D model of the tunnel. So I'm going to go to 3D model draw. enter the initial and final station and the number of the points you want to use to create the model. And here the 3D model of the tunnel. You can see a 3D orbit. And also after creating the 3D model, we can do a route inside the tunnel, or even export to different formats like IFC, OBJ, or OSF. So in this case, we are going to export to Beam. And if we go to the project folder, we can open the IFC file with Beam Vision, for example, and here you can see the 3D model. And that's all of the demonstration of TcpTunnel and TcpTunnel CAD. Thank you for attending.
Thank you. That was great, David. Appreciate that. So Riley, will you give me back the screen?
Yes. You should be getting it pretty soon.
Yep.
Perfect. We can see the presentation.
Great. Welcome back. So I showed this slide before. I'm showing it again intentionally. Just to reiterate what we've said and what you've seen, the workflow starts in the office. We create the tunnel. We define the tunnel by template and by template assignment. We then take that information out to the field for either an initial survey, a stakeout of what we've designed, or a quality check of what we've built, right? We're showing that field work being accomplished with the Focus 35 and the Spectra ST10 data collector running the TcpTunnel software on it. And that is the Spectra part of this equation. And the office part and the software part is the Aplitop piece of this equation. So it's a true partnership here. I think I will let Riley speak to this slide.
So anyone who's interested in either purchasing or demoing the Aplitop software with the Spectra Geospatial Focus 35 total station. So Aplitop has we have two essentially options. You can contact Aplitop directly to purchase TcpTunnel, TcpTunnel CAD software. Also get demo licenses if you'd like to try it first. They also have a fantastic support and training team and a lot of materials available as well if you're looking for any videos or how to do the same workflows that David was showing. If you worked with a Spectra Geospatial dealer, and you already have maybe a Focus 35 instrument and you want to test out the software, I recommend reaching out to that Spectra Geospatial distributor, and they will help you get in touch with a demo license of the TcpTunnel software. And just to reiterate kind of the elements that are in the components of what we talked about today. So one, the TcpTunnel field software, which can run on a ST10 tablet with a Focus 35 robotic total station. And then the TcpTunnel CAD software, which David showed, where you're creating the design templates and the reports and so forth, runs on AutoCAD and ZWCAD as well. And then also, if you happen to be using Survey Office with the tunneling module, and let's say you already have some tunnel designs in that software, you can export out a TXL file and get that into the Aplitop tunnel software as well. It'll bring the design information as well. If you have just any general inquiries or questions, feel free to reach out to Joe or myself on the Spectra and Trimble side, or if you're interested more specifically on the TcpTunnel software side, Hugo has left his email address at the bottom there, and so feel free to reach out to Hugo as well.
Awesome. Thank you, Riley. So
Thank you, Riley.
there are a lot of resources on the web for both Aplitop and Spectra Geospatial. And here, because Riley has turned this presentation into a hot linked PDF file, if you go to that download section of this webinar and you download this presentation, all of these links to the various locations on the internet should be hot and live, and you should be able to click right through. Oh, went too far. So again, these are hot links. If you download the PDF file that Riley has created and uploaded, you can go directly to these web pages. It's fairly easy to find on the Spectra Geospatial website. If you go to Solutions and then you click on the tunneling survey, you will find these pages that are shown here. And as indicated before, but not really said, reach out to Riley or me if you have questions on the Spectra side of things. We'll be able to direct you or advise you in the correct way. So, with all of that being said, I think we've imparted our message, and we'd like to open it up for any questions that have not yet been answered.
Yeah, there's a question here. David, I think you're probably the best one to answer this. So the question came from Joan about they want to take a 3D model IFC design that they've received from their client, so a tunnel design in IFC format, and import it into the TcpTunnel CAD software and use it, create the sections from that. Is that possible with the TcpTunnel software?
Now it's not possible. Now it's only possible to export to IFC, but not to import data from IFC.
Okay, so to confirm, you can export IFC out of TcpTunnel CAD, but you can import design information at this moment.
No, the current version of the program doesn't support that.
Okay. Another question that came in from Piotr was about running TcpTunnel CAD software on the ST10 tablet, which I think is possible. I've actually never done it myself, but because the ST10 is a Windows OS, you should be able to run it. The only challenge is it's a much smaller screen than your laptop or your desktop, so it'll be the menus and icons will be a little bit smaller in AutoCAD.
Yes, you can run both programs on ST10.
Yes,
yeah,
awesome.
It's possible.
Cool. All right. Well, we have lots of time left, so if anyone else has any questions, feel free to put them in the chat window in the GoTo webinar screen, and we can answer those. We'll give some more time here for other questions to come in. Another question, David, probably for you. What formats can I export from TcpTunnel CAD for the tunnel design?
The tunnel design. Now you can export to TXL file.
Okay.
Well, you can import from TXL file. Yes,
okay.
But the format of the files are proprietary Aplitop files. Okay.
Okay.
So you can.
Yeah, and for just so everyone is aware on the call, the TXL file is the Trimble tunnel design format, which comes out of the Survey Office tunneling module.
Well, and just to be fair, and Trimble Business Center.
And Trimble, yes, correct. Another question came in. Just give me a second to read it. So with TcpTunnel CAD, you can have variable design template changes. So I can move between multiple shapes. So if my tunnel design shape changes multiple times throughout the alignment, I can have as many shapes as I want in that tunnel design. Is that correct?
Yes, you can create a different tunnel template and you can assign along the horizontal alignment. Okay. And the program automatically interpolates the tunnel templates in the different stations.
Okay, perfect. All right, so let me look, see if there's some more questions. Jose asked a question about convergence monitoring, I believe, monitoring in the tunneling works. Is there any reporting or analysis functions in the TcpTunnel software for collecting monitoring data?
So I can understand the question.
Yeah. So the question is around 3D and convergence monitoring. So when a surveyor is measuring the same points multiple times over time, so they have, let's say, points 1, 2, and 3, and there's multiple measurements at each of those points. Is it in the TcpTunnel software? Are they able to calculate displacements? So the change between those points?
Yes, you have an option in the check menu to calculate the difference between 2 points measuring different days.
Okay. So Jose, if that answers your question, let us know if you have more specific around monitoring. Just feel free to put it in the chat. Okay, the Jose came back. So is there specific monitoring reports though? So you mentioned they can use the check feature to calculate the difference, but is there any specific monitoring reports in TcpTunnel?
I don't understand what you mean.
That's okay.
Sorry.
No, it's okay. I don't think there is, but I'll be honest, I'm not an expert on TcpTunnel.
I have not seen this either. David, maybe if we said, is there a way to report on displacement over time?
Or movement.
A report of the offset report.
No, it would be slightly different than the offset. How about let's discuss this after, and Jose will get back to you. We'll send you an email after this webinar to clarify.
Okay, it's better. Mm-hmm.
Yeah, for sure. So a question from Vinay came in about TBM tunnels. Are there any features in the TcpTunnel field software for TBM type tunnels?
For TBM, no, there are no options for TBM.
Okay, so it's for more drill and blast, NADM, SEM tunnels. Okay.
What TBM is a bore machine?
Yeah, so tunnel boring machine. So it's kind of essentially two ways of building tunnels, not two, but those are the two primary. And one is drill and blast and excavation, which TcpTunnel is perfect for, especially because of the automated as-builting routines, right, where they're constantly collecting as-built profiles. TBM tunnels, because the machine is kind of boring and putting foundation in at the same time, there's kind of slightly different survey requirements for TBM tunnels versus for the drill and blast tunnels. Actually, Vinay, if you want to, if there's any specific features that you think would be useful in TcpTunnel for that, please add them to the chat window.
And I would also say that even after the fact, Hugo is wide open to ideas. We had his email address up there.
Yeah,
I'm sure he would accept ideas directly.
I'll give one more minute to see if any more questions come in, and if not, we'll close the webinar. I just want to remind everyone that this webinar will be recorded, so if you want to share it with any of your colleagues or you want to view it again, you'll receive an email shortly after this with that recording link. And also in the handout section in GoToWebinar, the PDF of this presentation is included, so you can have that, and it's got all of the links that Joe mentioned before as well for all of the different social media as well as the training materials.
From my side, I would like to thank all of you guys for participating today, for showing up and attending and listening. I hope you got something useful out of it. Our email addresses were put up there intentionally. If you want any questions answered or you would like any clarifications, please reach out to us. We're working from home.
Perfect. Doesn't look like there's any more questions at the moment, but we'll get in touch with Jose and any others who want more clarification. Feel free to send any of us an email and we can chat more about this. Thanks everyone. Thanks David and Hugo and Joe for a great webinar, and we'll see you all again soon.
Have a nice day, everybody. Bye-bye.
Thank you. Bye.
Bye. Have a nice day.